Alright, so in this version, to pick up now, we go to the second part of it. Well, in the second part, you can see that we multiply the e right here. We can multiply the e by x and we'll multiply the e by t. And when we do that, we'll get the ex plus the et, that's expected value of this, which x could be any number. But since this one is a constant value, like 2, like 1, it could be just one single number. That's just like a single number. And look at over here, the mean of a single number is going to be the same number. So that's the reason why the expected value of a constant is going to be same as that. Let's talk about the measure of spread. Let's talk about the measure of spread. And then in this part, I will talk about the measure of spread. Actually, guys, I'm still going to come back to these properties. We're going to use it to prove some variation. But for us to do that, let's talk about the measure of spread. Let's talk about the measure of spread. All right. So to think about the measure of spread, let's do it this way. This is the measure of how spread apart are the data from the central point. Now, when we use the word central point, the central, and we say the central point, take note that the word central point is the same thing as the expected value. And you know, when I say the expected value, that is definitely the mean, is that not? The mean. That is the mean. That is definitely the mean. So the expected value, which you agree with me, will represent that by that, and the mean, which is represented by that, so which is the weighted mean. So in that way, when you're talking about the central point, you're talking about the measure of spread. You're talking about how spread apart are your data from the central point, from the center of your data. How spread apart are they? Now, I'll give you an example here, which is a very, very basic example. Let's take a number like 2, take a number like 4, and let's take a number like 6. Okay, let's take this number. Now this number is 246, right? So this 246 of a number. What I want to find here is I want to find the center of this number. Let's assume I have those values. All right, so we can say they are maybe weights, and let's call them 2 grams, 4 grams, 6 grams. Now these are values, okay? These are weights of an object, okay, which we can give x variable. We can give that x variable. Now what I want to do from here is I want to find out the normal mean of this value. To figure out the normal mean of this value, you will agree with me that the normal mean of this value, right, is so basic. All we just have to do is to say that the mean of this value is going to be, what would it be? That will be 2 plus 4 plus 6. You agree with me? Mean is the same thing as average. Okay, so take note that when you say mean, this is definitely same concept as average. You don't want to forget that that is also average. So when you say the mean of something, you also mean the average of that thing, the expected value, and the central point. All of these are the same thing. Do not forget. So in this way, we want to take the mean of this value, which is we're looking for the average of 246. We're looking for the center of 246. And to find that, we will divide that by how many? By 3. Since there are 3 of the number. So 2 plus 4 plus 6 is going to give us 12. And you have 12 divided by 3, and that will give you 4. Now that I've gotten 4, I'd like you to look at what I'm going to do with this piece of information right now. Okay, so the center point is 4. See, I've put 4 there. Now, this 4 is the center point of this data, which means 4 in here, I could take that 4 as the center point of the data. Right? So if 4 is the center point of the data, what does it mean? Now, in this case, I will do something for you. Okay? So I'm going to take the first number, which is 2. I'm going to take 2. All right? And I'm going to put 6 here. Now, what I want to check here, independently here, is the distance. Okay? I want to check in here the distance of 2 to 4 and the distance of 6 to 4. Is it going to be the same thing? If you say 4 is the middle point, if 4 happen to be the middle point between 2, 4, 6, and this 4 is the middle point, that means from 2 to 4 and then from 4 to 6 must be same distance. The spread must be the same spread, the same distance apart. Must be at the same distance apart, must be at the same spread apart. Does this make sense? So we want to do this now. To do this, don't forget that this is my main value. I'm going to call this my main value. And what do we get for this one? This value here is a x value. And this value here is also x value. We can call this x1 and call this one x2. So what is going to be the distance between here and here? You have two options. It's either you are saying 2 minus 4 or 4 minus 2. Either way you're doing this. So you want to say 2 minus 4, you will get negative 2. 4 minus 6, you will also get negative 2. Did you see that? Same figure. 2 minus 4, negative 2. 4 minus 6, negative 2. But we're not going to do it that way so that you guys could get it all straight in here. Let's punch it like a arrow in between the two space. So now 2 minus 4, that's going to give 2 minus 4, is that not? And in here is going to be 6 minus 4. Okay, so that makes some sense. So 2 minus 4 is going to be negative 2. And 6 minus 4 is going to be 2. Now, the question is, they are not equal. Hold on. Look at the formula I use here. It is x minus bar x. That is the formula I'm using. Now, you see this here is called deviation. That's what we call it, deviation. Now, when you sum up all your deviation, you must get 0. So if you go ahead right now and add minus 2 and plus 2, you get 0. To tell you that 4 is the exact center of 2, 4, and 6. So the deviation must always give you 0. X minus bar x must give you 0. Deviation must give you 0 because the center of the data is 4. So at any point you find your distance, by the time you sum up all those distances, it must give you 0. Does that make sense here? So the deviation is x minus bar x. But because if we sum up x minus bar x, we're going to get 0 because there will be negative number and there will be positive number. So what we do here, right, is to square our deviation. So we then square our deviation by saying our deviation should be x minus bar x all square. So if you square it like this, all the negative number become positive number remain as positive number, and therefore the summation of this our deviation is no longer equal to 0. But if you take the sum of deviation, it is equal to 0. You just want to get this straight right now. Okay, so when we do this, that one is not equal to 0 and the other one is equal to 0. So the measure of spread is being done, right, by looking at how spread apart are your data, how far apart are your data, how movable away are your data, what is the distance of the center value away from every other value that you mentioned. That is what the measure of spread is talking about. And to treat this, we do not just use deviation. Instead, we use variance and standard deviation. We use these two